Okay, this is lesson number 46 in Algebra 2, more on radical expressions, radicals to fractional exponents. We're going to do two things in this lesson, and good to pay attention because these can be a little tricky. I'll try to make them as simple as possible. We'll see what we've got. 3 times 5 over 2 plus 3 times the square root of 2 over 5 minus the square root of 90. All right. What we're going to do here is we're going to look at each one of these terms individually, okay? And let's go ahead and look at this one first. So, let's change this to 3 square root of 5 over square root of 2, okay? We can't have a radical in the denominator, so I multiply top and bottom by that, and I get 3 square root of 10 over 2. Okay? Okay, so this turns into that. Now let's look at this next one. Draw a little line here so I don't get things in the way. So we've got a plus 3 square root of 2 over the square root of 5. Multiply top and bottom by the square root of 5 to get rid of the radical in the denominator. 3 square root of 10 over, oops, that's a 5, isn't it? Over 5 minus the square root of 90. Square root of 90 can be broken down into 9 and 10. So the square root of 9 is 3, so we can pull that out. The square root of 10 has to stay there. Alright, so now we have 3 numbers with radicals all being 10, which these were made this way so that they would work out easier. So anyway, this is over 1. We need a common denominator so we can combine these. So you can look at it as, okay, what am I missing here that I have here and here? Well, in this case, it's just a 5. So let's do blue. I'm going to multiply top and bottom by 5. And then I look here, say, what am I missing? I'm missing a 2. So I'm going to multiply top and bottom by 2. And over here I'm missing both a 2 and a 5. So let's look at see what we have there. We have 15 on the top, square root of 10 over 10, plus 6, 3 times 2, square root of 10 over 5 times 2 is 10, minus this is 10 times this 3. Okay, I've got the same number under the radical. I have the same denominator, so that means I can combine these. So 15 plus 6 is 21, minus 30 is negative 9, and everything else stays the same, because when you add or subtract fractions, you don't do anything with the denominator. When you add or subtract anything with radicals, you don't change the radical. They're the same radical. That's the only time you can add or subtract them. Since they are the same, you just tag them on there, and we get negative 9 square root of 10 over 10. And this is different than 46.1 example. I don't know what they were doing there, but anyway, that's how you solve those, and that's the only example they give you. So let's jump to radicals to fractional exponents. And what it means to change a radical to a fractional exponent, it means to take something like this and rewrite it as that. Okay, so remember, the bottom number is the root, the number in here. In this case, it's a square root. The 1 is the exponent on the 3. So, for example, if I had the cubed root of 6 squared, that would be 6, exponent on top, index on the bottom. That would be 6 to the 2/3. Okay, so it's just another way of rewriting a radical. In fact, sometimes it's easier to leave it as an exponent, sometimes it's easier to leave it as a radical, and that's just something that comes with practice that we're going to be doing, switching back and forth. So what if I had the square root of 3 square root of 3? A radical within a radical. Doesn't that like make your head explode? Alright, so we're going to take the innermost one, change it to an exponent. Then we're going to change the outer one, this one here, into an exponent. Okay? So we have 3, this 3 to the 1/2. This 3 we have to the 1/2 times 1/2, which when there's no sign between them, you multiply them, remember? And then when you multiply those, what do you do with exponents? You add them. So we get 3 to the 3/4 power at the end. Alright, let's try another crazy one. See if I can get rid of this without taking too much time. Ta-da! Alright, so cubed root of the square root of 3, square root of 3. I hate it when they do that and have all those 3's because it gets you confused. Alright, so we're going to start with the middle, or the inside. Okay? Now we're going to take this one off. So let's make a bracket here, and we'll leave our 3 to the 1/2 here. But what happens for our exponent? It becomes 1/3 because our index is a 3. So let's take 3 to the 1/3, and then we're going to take these. 1/2 times 1/3. That equals 3. Do you understand why I can add these exponents? Only because these are the same number. If those were not the same number, I couldn't do that. So this is going to change to a 6 and a 2 so that I can add those. And 3/6 is the same as 1/2, which equals the square root of 3. So this big monster here is actually, when it's simplified, the square root of 3. Alright, we've got 2 more examples here and then we'll be done. See if I can erase the whole thing. Alright, so we've got x cubed y squared radical cubed root x y. Alright, so let's see what we've got here. We're going to write this as x cubed y squared to the 1/2 power xy to the 1/3 power. So we're going to do what I've got here. X times 3 times 1/2 is 3 halves, 2 halves. X to the 1/3, y to the 1/3. Okay, now we can add our exponents. We've got our x's, then we've got our y's. That's actually, well, let's just leave it 2/2. Okay, so these we have to find common denominators for. Let's do that in blue up here. X to the, let's see, 9/6 plus 2/6. So that gives me 11/6. And my y then is going to be y to the, let's see, we're going to have to do 6's, aren't we? Plus y to the 8/6, which this then reduces to 4/3. So x to the 11/6 plus y to the 4/3, and we're done. Okay, this is example 46.6, last one, and what we're going to do is we're going to take that and get rid of the radical sign. So we're going to put it to the 1/3 power. Then we're going to take the next one, xy to the 5th, and take that to the 1/4 power. And then again, we use the power rule, multiply the 5 times 1/3. Then we've got y to the 3 times 1/3, which is going to be 1, 3/3. Then we've got x to the 1/4 and y to the 5/4. So not much to do there. Now we're going to combine our x's. Let's do that in blue. To the 5/3 plus 1/4. So do you see why I'm adding here, but up here I multiplied? Because see, this is outside the parenthesis. Whenever there's a parenthesis, you're multiplying this exponent times this one and this exponent times this one. When there's no parenthesis and they're just side by side, they're in line. See how this one's above this one? That shows you're multiplying. But when they're next to each other like that, you're going to be adding. And then we've got, whoops, y to to the 1 plus 5 over 4. So this here, let's move up to the top. We have x to the, so we need a common denominator. Between 3 and 4 is 12. So 3 times 4 is 12, 5 times 4 is 20. And 4 times 3 is 12, and 3 times 1 is 3. So then we have x to the 23 over 12. Not a very pretty one. Now let's add these. So we've got y, common denominator would be a 4. I'm assuming you know how to do that, or you wouldn't be in Algebra 2. And we get that for an answer. And no matter how ugly that is, you're going to get answers that look like that. That's okay. Alright, so problem set. Nothing really weird. A, B, and C shouldn't give you any trouble. Again, we're skipping story problems, jumping down to 6 to 15. And numbers 10 and 11, well, it looks like 6 through 11 are all from this lesson to give you some good practice. Gosh, they look very, very similar to the video we just did. 14 and 15, you're using some trig stuff. You're going to skip 16. And everything else looks like same old, same old. Careful on 27 and 28. You're going to do both of those. Make sure you find, or make sure you multiply the entire problem by the common denominator. Like number 27, you're going to multiply the whole thing by 6 and your fractions will go away. Number 28, you're going to multiply the whole thing by 12 and your fractions will go away. Don't forget to do that. Too often people try to mess with these fractions. Get rid of the fraction. If there is an equal sign and you have fractions, find the common denominator and multiply the whole equation by that number, and that'll get rid of all your fractions. Alright, so that's lesson 46.